All right, future engineers, listen up. The JEE clock is ticking, and I know that Amines chapter looks absolutely massive. But what if I told you that you could pretty much master it in the next few minutes? Let's do this. This isn't going to be just another boring revision. Nope. This is your strategic master key, and we're only going to focus on the stuff that's guaranteed to get you the most marks.
So, forget trying to read the entire textbook cover to cover. We're going to do this backward. We are literally going to reverse engineer the JEE exam by looking at what the examiners absolutely love to ask, year after year. It's all about studying smarter, not just harder.
So, this leads to the big question, right? The one every single student has. With so little time left, where should you focus your energy to get the biggest bang for your buck? Look, you can't learn everything. That's just a fact. But what you can do is master the topics that matter the most.
And boom, here is your answer, laid out plain and simple. The data from previous year's questions doesn't lie. Diazonium salts, reactions with nitrous acid, and those famous named reactions like Hoffman and Gabriel, these are the heavy hitters. They consistently take up the most space on the paper. So let's start with the absolute king of them all.
Okay, let's jump right into the five-star topic, diazonium salts. Seriously, if there is one single area in all of organic chemistry that can unlock a massive chunk of your marks, this is it. You master this, and trust me, you are already way ahead of the game.
Take a good look at this. This single diagram right here is your entire battle plan for diazonium salts. Pretty much everything you could possibly need for most questions is laid out right here. See how all those reactions, Sandmeyer, Gatterman, Balz-Schiemann, they all just branch out from this one central molecule? You need to take a mental snapshot of this map. It really is that important.
Okay, feeling a little overwhelmed by that map? Don't be. We can just break it down into this super simple table. If you see copper chloride, you get chlorobenzene. If you see water and heat, you get phenol. HBF4, that gives you fluorobenzene, and H3PO2, that just gets rid of the whole diazo group, leaving you with a plain old benzene ring. See? It's really just a matching game.
So, what's the crucial takeaway from all this? You can boil down, I'd say, 90% of the questions to this one-line shortcut you see here. Q pred X gets you the halide, heat gets you the alcohol, and BF4 gets you the fluoride. Burn this into your memory. It is the ultimate trick.
All right, building on that, let's add a few more key reactions to your arsenal. Beyond diazonium salts, the exam loves to test you on specific ways to prepare and identify amines. So think of these next few slides as your essential toolkit.
Hoffman and Gabriel. They sound kind of similar, and that's why they're always tested on their differences. Here's the key. For Hoffman, you have to remember that you lose one carbon atom. You start with an amide, and you end with a primary amine that's one carbon shorter. Gabriel also makes primary amines, but, and this is a big but, it cannot make aromatic amines, like aniline, where the nitrogen is stuck right on the benzene ring.
So, how do you tell a primary, a secondary, and a tertiary amine apart in a test tube? You use the Hinsberg test, and it's a super simple three-step process. You add the reagent, then you add an alkali like KOH, and then you just watch what happens.
And this slide shows you exactly what you'd see. A primary amine forms something that just dissolves in the alkali. Gone. A secondary amine forms a product, but it stays solid, insoluble. And a tertiary amine, it just sits there. It doesn't react at all. This really clear visual difference is everything.
Now, what if you need a super quick, definite test just for primary amines? Well, then you use the carbylamine test. If you've got a primary amine, doesn't matter if it's aliphatic or aromatic, it'll react and form an isocyanide. And these things have a truly disgusting, foul smell you will never forget. So if you smell it, you've found a primary amine. Simple as that.
All right, everybody lean in for this part, because this is really important. Knowing the reactions is only half the battle. The other half is not falling for the simple mistakes that cost you easy marks. These are the traps the examiners love to set.
Trap number 1, temperature. Diazonium salts are incredibly unstable. The whole reaction only works when it's cold, between 0 and 5 degrees Celsius. If the temperature gets any warmer than that, poof, the salt just falls apart and turns into phenol. So if you ever see that temperature range in a question, it's a massive clue.
Trap number 2, trying to nitrate aniline directly. It seems so simple, right? Just add nitric acid. But no, this is a classic rookie mistake. The strong acid will literally just oxidize and destroy the aniline molecule. The right way to do it is to protect the amino group first, usually by turning it into acetanilide. Then you can proceed.
And the third big trap? I know we've already touched on this, but it is so common that it's worth saying one more time. The Gabriel phthalimide synthesis is awesome for making primary amines, but it will absolutely, positively fail if you try to make an arylamine like aniline. It's a fundamental limitation that they just love to test you on.
Okay, final skill. Almost every single GE paper has a question that asks you to arrange a bunch of amines in order of their basicity. It's a guaranteed question, so let's make sure you can nail it every single time.
So the first thing you have to notice is how the order completely changes depending on the phase. In the gas phase, it's super simple. The more alkyl groups you have, the more basic it is. So tertiary is greater than secondary is greater than primary. But in water, in the aqueous phase, the order gets all jumbled up. Why? Well, it's a mix of things, but mostly what we call solvation effects, which is just a fancy way of saying how well water molecules can crowd around and stabilize the ion. So, rule number 1, always check which phase the question is asking about.
Let's put this into practice right now. Take a look at this. This is an exact question from a previous JEE paper. You've got a few different amines here. So, based on what we just talked about, go ahead and pause for a second. How would you arrange these? Which one is the strongest base and which one's the weakest?
And for aromatic amines, like different versions of aniline, the shortcut is even simpler. Just think of it like this. Electron-donating groups push electron density onto the nitrogen, making it more basic. Electron-withdrawing groups pull that density away, making it less basic. It's really just a simple push and pull game.
And there you have it, the topics that come up the most, the reaction maps you need to know, the common traps to avoid, and the rules for basicity. That is the absolute core of the amines chapter. You now have the map to get you through it successfully in the exam. The puzzle is right in front of you. So are you ready to solve it?